Light is energy. Light is also a wave. It travels through the vastness of space. Light waves are special. They are electromagnetic waves. This means they are made of electric and magnetic fields. Imagine these fields as two strings vibrating. They vibrate perpendicular to each other. They also vibrate perpendicular to the direction light travels. This creates a beautiful rhythmic dance of energy. We experience this dance as light and color. Light travels incredibly fast. It moves at approximately 299,792,458 meters per second. That's fast enough to circle the Earth over 7 times in just 1 second. This speed is a fundamental constant in physics. Light waves are fascinating. They can vibrate in all directions perpendicular to their path. This is called unpolarized light. However, we can filter light. We can make it vibrate in only one direction. This is called polarized light. Think of a jump rope. Imagine it being shaken up and down and side to side. This is like unpolarized light. Now imagine the rope going through a narrow slit. The slit only allows the up and down vibrations to pass. This is polarized light. Scientists use a special tool to polarize light, the Nicol prism. This prism is made from a crystal called calcite. Calcite has a unique property. It splits light into 2 rays. These are called the ordinary ray and the extraordinary ray. The ordinary ray is absorbed by the prism. The extraordinary ray passes through. This ray is now polarized. The Nicol prism is a crucial tool for studying and using polarized light. Polarized light is not all the same. There are different types. One type is called plane polarized light. Here, the electric field vibrates in a single plane. Another type is circularly polarized light. In this case, the electric field rotates in a circle. Finally, there is elliptically polarized light. Here, the electric field traces an ellipse. These different types of polarization have unique properties and applications in various fields. Light can become polarized in several ways. One way is through scattering. This happens when light bounces off tiny particles in the atmosphere. Another way is through reflection. When light reflects off a surface at a certain angle, it becomes polarized. 2 important laws govern polarized light: Malus's law and Brewster's law. Malus's law describes how the intensity of light changes as it passes through polarizers. It helps us understand how much light passes through at different angles. Brewster's law, on the other hand, helps us determine the angle at which reflected light becomes completely polarized. This angle is important in designing anti-glare surfaces and polarizing filters. Polarized light has numerous applications. We use it in sunglasses to reduce glare. Photographers use polarizing filters to enhance colors and reduce reflections. Liquid crystal displays, or LCDs, in our phones, TVs, and computers rely on polarized light to function. Engineers use polarized light for stress analysis. This helps them design safer structures. Polarized light also finds applications in optical instruments, telecommunications, and even in studying distant stars and galaxies. The understanding and application of polarized light have revolutionized various fields. From reducing glare in our daily lives to unraveling the mysteries of the cosmos, polarized light continues to play a crucial role in science and technology.